Hello, everyone. Welcome to Industrial Sonomechanics live webinar on water-compatible nanoemulsions, the battle of formulations. My name is Eva Gyurgina, and I'm the Director of Marketing at Industrial Sonomechanics and today's webinar host. In this webinar, we'll discuss many important aspects of the nanoemulsion formulations. This topic is relevant to many industries looking to make any water-based products infused with cannabis extracts, essential oils, terpenes, or other active ingredients and oils. The webinar will begin with an introduction from Jeff Meyer, ISM's Executive Vice President and Chief Operating Officer. After that, we'll have more in-depth technical information presented by Dr. Alexey Peshkovsky, President and Chief Scientific Officer at Industrial Sonomechanics. We'll also be running a live Q&A session at the end of the webinar, and you can submit your questions at any time by typing them into the Q&A box. It's located at the bottom of the Zoom screen. And you can also mention whether you would like Jeff or Alexey to answer that question. And as usual, we'll try to get through as many questions as we can. And if there are any questions unanswered, we'll do our best to answer them offline after the event. So now I'm going to pass the mic to Jeff. Enjoy the webinar.
Thanks, Eva. Appreciate it. Hello, everyone. We're excited to come talk to you today. We'd like to be in person with y'all at a show or exhibit. We can't do that, so we're gonna reach out to you through this webinar today. So our team was thinking about, we wanted to do a webinar, and we were like, what should we do? What are people interested in? And all we had to do was start tracking the number of questions, calls, inquiries we get from thousands of customers, potential customers, growers, producers, branders, retailers, calling us asking questions specifically about our water-soluble nanoemulsions, how they are made, how to define them, how to measure them. And so we decided to put this webinar together. And I'm going to open it up with just a few slides just to kind of level the playing field, create a platform that Alexey will then take further and deeper. So first, I want everyone to know from just a pretty clear perspective that nanoemulsion, that word matters. It is a technical term with a precise definition that supports it, and it's not trivial. We talk about droplets of oil and water in the range of 20 to 300 nanometers. So when you're out in the industry and you're having discussions with people and you refer to nanoemulsions, understand that that's the baseline of that discussion, that it is about these droplet sizes. And it does require advanced equipment in an emulsifying package to produce, which brings me to my next slide, if you could. So again, big picture, what's required to produce this water-soluble nanoemulsion so that we can have a discussion when you call us or you're out there in the marketplace? It's pretty simple from the perspective of what's included, right? It gets a little more technical when we pull the covers off and peel back the onion. But at its very core, the water-soluble nanoemulsion, you're going to require your bioactive. And it's CBD, but it's many other bioactives out there. And I don't want to make this a CBD concentric issue because there's many bioactives that you can create water-soluble nanoemulsions for. 2, you're going to need water. But you're also going to need the right equipment. And that comes in the form of Industrial Sonomechanics ultrasonic processors that have scale-up capability. They can go to flow-through, right? So that's what we want to get people to be able to produce volumes. And we're going to show you a little bit about that later as well. But you're also going to need the right emulsifying package. And that's the comparison. That's the battle of the formulations. We people talking about what they want to formulate from a water-soluble nanoemulsion. This emulsifying package is key. So let's go to the next slide real quick. And talk a little bit more about that. So when you call us, this is what's in our head, right? I want to give you I don't want to give you too much of a look into my head. It's scary, but let's just start with this idea about a water-soluble nano-emulsion. When you call us, the questions on the left are the questions we'll ask. What concentration are you looking for? What kind of target droplet size in your nano-emulsion? And related translucency. How clear and visible do you need that product to be? What's the taste? What's it going into? What's that end product going to consist of? All those things inform us about what that emulsifying package will look like, which is going to lead us to this next question we're going to ask, which is internally, you should also be asking, what's my per dose cost? Where do I need to hit in order to make my margins where I want them to be? What's the retail price? And then work that back up the vertical. You're also going to want to discover within your own business what your internal technical competency is. You're going to have to ask the questions internally, whether people understand some of these requirements. And there's a processing complexity that comes with this. So while we like to say we make it easier by providing this emulsifying package, this nano stabilizer, if you will, you still have to jump into the pool here a little bit with us and have these discussions. Which brings me to my next point. So when you start looking at these liquid nano-emulsions versus powder nano-emulsions, right? This is a real quick, comparison table, and it's very rudimentary, I agree. But as you're starting to think initially about what path you want to go down, you want to start thinking about what equipment's required. And I do want to make mention that within the equipment side, if you want to create that powdered nano-emulsion, you're going to need a drying solution on top of our ultrasonic processors. If you want to create a liquid nano-emulsion, the emulsifying agent in our world is either going to need, you can create that nano-emulsion with both our LT and LSO product, which Alexi will mention a little bit more in a few slides. If you want to create the powder, that's really the LSO product. And if you want to worry about the concentration, they're both flexible solutions. You have a lot of flexibility for concentration decisions for both the liquid and powder and nano-emulsion using our emulsification package. So that's really one to kind of lay the groundwork for today. And then Alexi's going to dive a little deeper. I'm handing it off, Alexi, virtually to you.
All right. Hi, everyone. Thank you very much, Eva and Jeff, for the introduction. And welcome, everyone. It's good to have you. I will talk more in depth about what it actually takes to convert a bioactive oil, for example, CBD, THC, cannabis extract, or delta-8, or coenzyme Q10, curcumin, or something else bioactive that is oil compatible and not water compatible, into a water compatible form, which could be a liquid or a powder. And the product would ideally behave in this manner. You would be able to dose it, whether it's a powder or a liquid, into water or another beverage. And because it's water compatible, you would just need to give it a stir, and it homogeneously distributes itself throughout the beverage. If the droplet sizes are small, and we'll get into that in a minute, it can actually become transparent, which is ideal because it wouldn't alter the visual appearance of the product that you're dosing. And also, as we'll see, it leads to the best performance, the highest bioavailability, and the shortest onset of action. Before any of this, we need to get one concept clear. What is a surfactant? Surfactants are going to be mentioned throughout this presentation frequently. So let's consider a material that dissolves in water, a sugar, or something else like that, something that dissolves in water. And let's separately from that consider a material that is an oil, olive oil, for example. Everyone knows that sugar won't dissolve in olive oil, but olive oil will dissolve in coconut oil, or a cannabis extract will dissolve in olive oil. Oils like each other. Polar things like sugar and water also like each other. So like dissolves like. It's a basic chemistry principle. But what if you took a sugar and fused it to an oil? So this is exactly this kind of a beast. This is a polar head. This part by itself would be just water soluble. This is basically olive oil, and that would be oil soluble. And they're connected to each other, forming very schematically a molecule that looks like this, where this green part is what dissolves in water, and the yellow part is what dissolves in oil. So it's an oil-water sort of compatible entity. Now, if you have a layer of oil and you have a layer of water, and obviously oil doesn't mix with water, so no matter how much you stir it, if it's just by itself, it'll separate into this kind of a layered structure. And they do the substances do that because they want to minimize the amount of common interface. And if you introduce surfactants into this thing, then they will arrange themselves naturally like so. Their heads will be pointing towards the water. That's because that's where they like to be, but the tails don't like to be there. The tails will be in the oil. This is why it's called surfactant. It goes on the surface, on the interface between dissimilar things. Now, what it actually achieves by doing that is that water looking out, that used to see oil that is not compatible with it, is in a way unfriendly to it, is now seeing very water compatible heads. The oil looking towards what used to be just water is now seeing these tails that are also friendly to it. So sort of both participants are now happy. Happy is not exactly a technical term, but if you brought it to the technical realm, it would just mean that their interface is relaxed, which lets them assume shapes that are otherwise difficult to assume. For example, a very small sphere. Small spheres have very high curvatures, and that stresses the interface. But if you relax the interface, you make that possible. And you also prevent these spheres, if they're oil spheres suspended in water, for example, from coming together, because there are entities sort of encapsulating them. That's why these things are sometimes referred to as nano-encapsulation strategies. So surfactants make it possible for these small spheres to exist, to be formed, and also they stabilize them after they've been made so that they don't come back together and so the oil doesn't separate. Now, with this in mind, what are some of the ways that oils could be made compatible with water? The simplest is macroemulsion. Macroemulsion is when you take an oil and you take a surfactant, maybe it's lecithin or something like that, and you have water, and you can kind of mix them together using some basic mixing technique. Stir it together or use a rotor-stator shear mixer or something like that. With this, you will likely be making what's called a macroemulsion. Macroemulsions are suspended droplets of oil in water, stabilized by the surfactant on the surface, where the droplets are pretty large. They're in the micron range, in the thousands of nanometers. But sometimes when it drops below 1,000 nanometers and hovers around, let's say, 500 or more nanometers, it's very, technically speaking, could be called a nanoemulsion, but it doesn't really belong in the nanoemulsion realm because it has different properties. Specifically, these things are unstable, they separate, they don't really improve the bioavailability, they kind of mimic what an edible would be in that sense, and they don't really shorten the onset of action. So we're not going to consider them further because you can't really make products like this. They will not be stable. The other popular, or rather what used to be popular about 20 years ago or so, are so-called self-emulsifying systems. And this is when you can introduce so much surfactant into the water that you fundamentally change the properties of the water. It's no longer really water, it's some other thing that is overall not as unfriendly to the oil. So oil can actually mix into it, get what's called solubilized, and exist in it in not necessarily spherical droplets form, although it could be a spherical droplets form, but it could be this kind of a bicontinuous arrangement as well. Typically, it's a combination of both, and this is stable, and it can be translucent or it could be even transparent. But the problem is that it requires a lot of this extra surfactant to exist in the water, which for practical purposes only works when you have no other options, because now you're basically stuffing your beverage with chemicals that really don't belong. And surfactants are quite limited. You can't really use mild ones. You have to use strong chemical ones in most cases. Also, these entities are stable unless you do something with them. Frequently, if you change the pH, they separate. If you dilute them, they separate. If the temperature changes, they separate. So they're finicky, and they're pretty much being phased out now throughout the pharmaceutical and food and beverage industry. The next one I want to talk about briefly is liposomes. It's a misunderstood, frequently misunderstood type of formulation. It's excellent. It's very advanced, but sometimes it's not even misunderstood as much as it's mislabeled. Liposomes have water on the inside. They don't have oil on the inside. So it's water, and in this representation, it's not really to scale at all. So there's a lot more water on the inside occupying most of it. Then there is a phospholipid bilayer, similar to a cell membrane, where oils can actually go, because this is a hydrophobic, oil-compatible environment. And then there's water on the outside. Liposomes are great for delivering water-soluble agents to specific target sites. For example, chemotherapy agents. They're typically placed in the interior. They can't spontaneously go through the phospholipid interface and come out and damage organs that they're not meant for. And then what you can do is embed a type of protein in the skin, in the membrane of this thing, and inject the suspension of these liposomes into the bloodstream, where the protein would find and bind to the target organ and release the chemotherapy only there. This is advanced cancer treatment. It could also be used for things like vitamin C in a much more kind of prosaic environment, where vitamin C is actually too fast, too bioavailable. So when you put it inside here, you slow it down a bit. You smooth out the spike of vitamin C. But they're not great for cannabis, because cannabis extracts are oils and other bioactive oils. They're oil compatible. They would only have to go into the skin, into the membrane, and that's not a lot of loading. So you go through the trouble of making these kind of difficult to make formulations, and then you can't really load them with anything. So most of the time when people say liposomes, they actually mean nanoemulsions. Sometimes they even say liposomal nanoemulsions, which is a contradiction in terms. Which is where nanoemulsions come in. In our opinion, nanoemulsions are the best of all of these. They're free from the drawbacks of macroemulsions because they're permanently stable. They have oil on the inside, filling the entire interior. So the loading factor of the bioactive oil is high. They don't have a lot of surfactant. They require a lot less, 10 times less surfactant than microemulsions would. But there's a catch. Like always, there's a catch. And the catch is that you need appropriate equipment. You need scalable, if you're going to do production, extremely high shear ultrasonic equipment that will be able to replace the chemical energy that you would use when going the microemulsion, the self-emulsifying system route. Instead of using chemicals to get there, you would use mechanical energy. The advantage being, once you turn off the ultrasonic processor, it's no longer present in your formulation, or its effects, that only the results of its activity, unlike in the microemulsion case where surfactant actually lingers on and has to stay there. So the catch is that you actually need the equipment. Let's get a little deeper into what nanoemulsions are. So this is a suspension of droplets of oil and water stabilized by these entities, they're surfactants. And they will comprise typically a carrier oil. Carrier oil is a long-chain triglyceride, although some people do like to use MCT oils. We don't recommend it. There's a bioavailability issue with those, and we can talk about it offline if anyone is interested. So a long-chain triglyceride into which you would place your bioactive, a cannabis extract or something else. You will need surfactants, and I have these two colors here because of oil and water combination that they are. And there will be less surfactant amount than the amount of oil, the total oil that you're emulsifying this way. You will need water if you're making a liquid nanoemulsion, or a binder, which is a water-soluble solid material that would be replacing water in an otherwise very similar structure that is a solid nanoemulsion, if you will, which can be converted into a powder and behaves in most ways in the same way as a nanoemulsion. It gets reconstituted into a liquid nanoemulsion once you place it in water. It could also be compressed into tablets and applied sublingually or just a quick disintegrating tablet. We recommend preservatives for liquids, especially if you're going to be opening them a lot, because fungus gets in and fungus loves this stuff. Now, for this type of suspension of droplets to qualify as a nanoemulsion, there are lots of definitions, but the most appropriate definition, in my opinion, is where the median droplet size would be lower than 300 nanometers. That pretty much makes the nanoemulsion stable. The lower the droplet size, the more stable the nanoemulsion. So you could qualify as a nanoemulsion under these conditions, but to be a good nanoemulsion, it's recommended that all the droplets are below 100 nanometers, which makes the D50, which is the median droplet size, well below 100 nanometers. That also makes nanoemulsions translucent, which is important for many cases for aesthetic reasons. It also makes it easier to understand when your nanoemulsion is good. When it's translucent, it's good. And if it gets cloudy, that means it's not stable for whatever reason, because the droplets grew. Ideally, the droplets should be in the range of 20 to 40 nanometers, and we'll get into the reasons why. This is what a droplet size distribution looks like. And anyone making these kinds of products, if you're interested in making sure that the nanoemulsion that you have is good, we strongly recommend that you run this analysis. Besides potency analysis that tells you whether you have your CBD in it or THC or what have you, it's important to get a droplet size analysis if you're speaking about a nanoemulsion. So this is a distribution of sizes that's present in this nanoemulsion. As you can see, this is a typical one that we produce or we enable our customers to produce. You can see that all the droplets are below 100 nanometers, which is why it's translucent. So the median droplet size is about 26 nanometers here. And this has 20 milligrams per milliliter of CBD extract. Now, this could also be formulated as a powder. In this case, when you place this powder in the water, you can measure the droplet size distribution. You can't do it while it's still in the powder form. But you don't even really want to do it, because for it to act, it would have to be in a liquid. That liquid could be your saliva. It doesn't have to be a beverage that you dose it into. So it could be a pill that you put under your tongue or just let disintegrate in your mouth. But there it will reconstitute back into a nanoemulsion with this type of droplet size distribution, slightly larger, still in a good range. Now, every once in a while, this question comes up: are these things safe? Are nanoemulsions safe? Nanotechnology is such a new thing; it's not been studied sufficiently. So, what I wanted to show in this slide is that perhaps the word nanotechnology is somewhat new, but nanoemulsions themselves are not new. English breakfast tea, for example, or any tea, is a nanoemulsion with a droplet size distribution extremely similar to this one. So this is 26 nanometers or so. This is 25 nanometers. McDonald's coffee is slightly larger droplet size, is 82 nanometers. lots of other things. Tea, beer, milk, actually our plasma, the environment of our small intestine, these are all nanoemulsions. Now, why is it that it's important to keep the droplets small? And what is this about 20, 25, 30 nanometer range that makes nanoemulsions good? I'm not going to go through this slide in detail. I cover it in several presentations that are currently online. But long story short, when you consume an oil, your small intestine will be breaking up the large drops of oil that arrive there, and you would consume an oil as part of your meal, for example, if it's salad dressing or maybe it's fat from the steak that you took or that you ate, or it could be a plant oil or an animal fat. When they arrive in the small intestine, they will be broken down into what's called mixed micelles. This happens with the help of microenvironment in the small intestine because your gallbladder produces phospholipids and bile salts that are surfactants, and there's peristaltic motion of the small intestine. So over time, with some liptases and lots of other things, you're able to break down these oil drops into mixed micelle droplets. The reason that you have to do that is because to get absorbed, oil particles, oil droplets, have to travel through a water layer. It's called unstirred aqueous layer to the absorptive cells, where they can actually get absorbed and then they can go into the bloodstream or lymphatic fluid. Large drops of oil can't travel through water. They just don't mix with water. But mixed micelles do, and that's because they are about 20, 25 nanometer droplets of oil. They can be smaller, but if they're swollen, they're called swollen mixed micelles. When there's a bioactive like a CBD oil or THC oil present, they find their way into these mixed micelles. And these mixed micelles can now travel because they can mix with water, much like nanoemulsion in the previous slides can, that I showed you how it mixes into a liquid. And now they can get to where they need to go. Your body does this thing naturally. And this process takes a long time. It takes an hour to even really get going properly. After about an hour and a half, it starts to happen. And that's why the absorption starts to happen, rather. And that's why when you consume an edible, you don't feel anything for an hour. And then after an hour and a half, you start to feel it. It's because now the micelles have been made. CBD or THC, well, if you're feeling it as THC, found its way into its interior. Now they were brought to the absorption cells, and now they're actually getting into your bloodstream, so you can start to feel them. But if you make this process happen outside of your body by nano-emulsification using an ultrasonic processor and the proper formulation, that what you swallowed, what you administered as part of your beverage are already these pre-digested nanoparticles of oil, nanoemulsion droplets. In most ways that matter, they're the same as mixed micelles, so that they can get absorbed almost immediately as soon as they arrive there. And their absorption is very efficient because you don't have to make them slowly while you're eliminating them, out of your body. So they're ready to go, and in that way they start to mimic what alcoholic beverages feel like. Being water soluble, they don't have to go through this process. So once you have a glass of wine, in 10 minutes you feel it, and then for a couple hours you feel it, then it goes away. That's what nanoemulsions of cannabis extracts start to behave like. In the way they become water compatible, if just not to say water soluble, because technically it's not correct, but they behave as if they were water soluble. Several interesting things also happen when you diminish the droplet size. The translucency improves. So when the droplets are, in this case, 177 nanometers, the formulation is opaque. Now, without changing any of the components, just continuing with processing this thing with an ultrasound processor, You reduce the droplet sizes, and then at 49, you can see that it's translucent, and at 31 nanometers, it's pretty transparent. This is published work. There's a reference down here. If anybody's interested in details, this can be found in this peer-reviewed journal. A very frequent question is, what about bioavailability? How does that depend on the droplet size? Intuitively, it seems that it should really depend on it, and it does. So this is another published paper on, it's a non-cannabis formulation, but the amplification of bioavailability belongs more to the way that you're packaging it, so to nano-emulsification itself rather than to a specific bioactive. So the conclusions are basically applicable across bioactive oils. So this is a very elegant paper where they administered orally nanoemulsions with different droplet sizes, but otherwise with the same active and the same amount of active. And as you can see on the bottom here, this is what happens when your nanoemulsion is really borderline. It's more of a macroemulsion, really, 400 nanometers droplet size. You're down here. As you reduce your droplet size, the bioavailability, or peak concentration in this case, in the bloodstream, but also the area under the curve, which speaks to the bioavailability, increases, reaching its maximum at about 25 nanometers. And so when people ask, well, by how much can I expect the bioavailability to go up? By what factor? According to this study, it's approximately a factor of 5. You're going from about 250, below 250, to just below 1250. So this assumes that 400 nanometers behaves as if it were just an oil capsule, which it actually doesn't. It behaves a little bit better than that. So I'm typically comfortable saying you can expect a factor of 5, maybe a little more, maybe 5 to 7 or so, pending rigorous studies of this for a specific bioactive, which is actually would be the right way to do it. So specifically for CBD, specifically for THC, we're hoping to be able to do a study like this within the next year or so. What does industrial Sonomechanics offer to those who want to make their own nanoemulsions? We offer ultrasonic liquid processors, starting from a laboratory scale. So this is an LSP 600 lab scale processor. It's good for small runs or research and development. Our medium system, bench scale system, is BSP 1200. With this system, you can make about approximately 25,000 nano-emulsified doses, if you consider 10 milligrams of, let's say, CBD or THC a dose, per hour. So 25,000 doses an hour, or about 5 liters of nanoemulsions an hour. ISP 3000 is our largest system. That can make 100,000 doses an hour, or about 20 liters an hour. This illustration is of the BSP 1200 processor, but all our processors look and are configured about the same. What changes is the size, but what doesn't change is the quality of the result, just the productivity. Now, the other side of the puzzle that Jeff already kind of alluded to, and I will dive into more in detail, is the formulation. We offer all-in-one formulations, nanostabilizer LT and nanostabilizer LSO. Both formulations include all the components that you will need. We call it R&D in a jar. All the R&D has been done for you. Everything is pre-mixed. All you need is your cannabis extract and a processor, water, and some common sense. The formulations are optimized to work best with our processors, although they do work with other equipment. It's just hard for us to predict what the performance will be like if it's not our equipment and we're not familiar with it, but we do have people who use it with third-party technology. They yield formulations of very high quality with very high bioavailability and very fast onset of action. And importantly, they require no formulating or processing expertise if you're using our processors, because we, in that case, would just provide detailed instructions step by step, so you can just follow them and you will get the product. And importantly, all the ingredients are very mild. They're all tasteless, and I'll get into them in the next slide. Now, if you're making powders, you will also need a drying solution. For example, spray drying. We also offer a solution ourselves in selected cases. In case you're interested in that, please contact us and we'll discuss it with you. Let's look at nanostabilizers in a little bit more detail. This is nanostabilizer LT. It's good for making liquid nanoemulsions. You can expect droplet sizes in the vicinity of 25, 27 nanometers. As you can see, it will be translucent, the nanoemulsion. It looks kind of like a paste, or like creamy paste. It easily melts, at mild heating, so something like 40, 50 degrees Celsius will melt it. You can mix it then with your cannabis extract, kind of dissolve them in each other. Add water and run it through the ultrasound processor, and you will get the nanoemulsion as a result. Nanostabilizer LT can be used in different ratios with respect to the bioactive that you're processing. In this case, CBD isolate was used. So the ratio we recommend is 5 parts of nanostabilizer to 1 part of CBD. Remember that nanostabilizer is not even mostly surfactants. There's a carrier oil and other things. So this ratio of 5 to 1 leads to very small droplets. So D50 is this blue line. D50 is the median droplet size. You can expect approximately 27 nanometers out of that. And D95, which is close to the upper edge of the distribution, will be about 52 nanometers. Now, if you want to use a lower ratio because of the cost saving or for whatever other reason, you can do that. At 4 to 1, you're still at an excellent nanoemulsion, 33 nanometers in the D50. Even at 3 to 1, you're at an excellent nanoemulsion. Everything is below 100 nanometers. It's translucent, very lightly translucent, but this is concentrated nanoemulsion. So if you dose it into a beverage, it will go fairly clear. But when you get to about 2 to 1 or below, what happens is the nanoemulsion is still good and it's still stable, but the upper edge of the distribution gets to about 200 nanometers. And it starts to become a problem if you're going to be sterile filtering it, because sterilizing filters have pore sizes in the vicinity of 220 nanometers. So when your droplets start to be comparable to that, you just start to clog up the filters. And you can use larger filters, and you will be mostly sterilized if you use a 450 nanometer filter, for example. But you won't be able to state that it's sterile, because officially sterilizing filters are at 220 nanometers. So we don't recommend anyone to go below about 2.5 to 1. So, but also exceeding 5 to 1 leads nowhere. It's diminishing returns. You're not really improving. So 5 to 1 is what we recommend. 2.5 to 1 is what we recommend to be the lowest ratio, and you could be anywhere in between. It's entirely up to you. Let's talk about Nanostabilizer LSO. This is a very recently released product, just a few weeks ago. And it leads to either liquids or powders. Actually, both. If you use this, you would first be making a liquid, which you can then dry without having to add anything else. Everything is already included in it. You could spray dry it directly or use a different drying technique, and you will be able to make a powder out of it. Interestingly, on the liquid side, when you first make it, the droplet size is about 140 nanometers or so, a little below. And after you dry it, powderize it, and put it back into water to reconstitute it, the droplet size won't change. This is a very important thing. Drying doesn't reduce its quality. Nanoemulsions made from this nanostabilizer are opaque. As you can see, the droplets are not below 100 nanometers, so it will not be translucent. But it is stable. Its bioavailability not as good as it can possibly be, but it's pretty high. And it can be made from, well, it's standard nanostabilizer LSO is made from organic ingredients. Sorry, natural ingredients, but optionally they can be organic. If you need them to be organic, come talk to us and we could do it as a special order. Otherwise, they come in the natural form standard. All ingredients are tasteless of both nanostabilizers. Nanostabilizers have no taste of their own. Let's talk about taste. This is a question that comes up a lot. Cannabis extract nanoemulsions are frequently bitter. In most cases, they're bitter. So where does that come from? The greatest source of bitterness is the extract itself. Cannabis extracts are bitter. Sometimes if you take an extract or CBD isolate and put it on your tongue, you might not perceive any bitterness, but that doesn't mean that they're not bitter. That means that they're not bioavailable because they don't dissolve in your saliva and they can't get to your taste buds. But as soon as you put them in a water-compatible form, you've amplified everything. You've made them bioavailable. Now they're also bioavailable to your taste buds. So the bitterness that was in there that you weren't perceiving, you are now perceiving. So there is an amplification due to the droplet size reduction. That's another, it's not a source, but it's a source of the amplification of the source of bitterness. And if your formulation is not a good one, the bitterness and all kinds of other tastes can come from that. If you use harsh surfactants, tweens and spans, for example, polysorbate and things like that, they have bitterness of their own. They're chemicals. We don't use anything like that in our formulations, and we don't recommend that people do. But they polysorbates are generally recognized as safe by the FDA, and so they are food grade. So you may choose to use them. Just know that the flavor will be affected. Now, what can you do? The first thing you can do is change something about your extract, because this is the source. There are two things you can do. You can either clean up your extract to try to get rid of the bitterness. That's difficult. Typically, you need to, well, at least winterize, obviously, because waxes are very bitter. Chlorophyll is terribly bitter. So you want to get rid of all that. But after that, what people do is a fractional distillation, sometimes chromatography column, sometimes both. That works. Typically, it's never 100%. There's always a little bit of something, but it might be fine. It might be good enough. We've seen some extracts that were just amazingly pure, very little bitterness. Even after you amplify the bioavailability tremendously, you barely perceive it, especially if you put it in enough water. But if you consume it straight, typically it's there. We, by the way, don't recommend that you consume nanoemulsions straight. They should be dosed into a substrate, into a beverage. Another approach would be the opposite. Leave the flavors in. Make them pleasant. Because bitterness seems to be the one that persists the longest. As you remove things from it, you lose all the nice, pleasant smelling and tasting terpenes and flavonoids and all that. And what you're left with is bitterness. Maybe less bitterness, but much less of other things. So I always think of cannabis beverages as something that shouldn't be tasteless. It should taste good, like whiskey, scotch. I wouldn't want tasteless scotch. First of all, I want to know that it's there. I want to be able to taste it in there. Second of all, it's acquired. It's an acquired taste, but I was very happy to acquire it in the case of scotch, and I enjoy it when it's good. So that's another strategy. Make it taste pleasant. Then you don't have to fight with nature. In either case, the formulation that you're using should not contribute to the taste. It should be tasteless. Our nanostabilizers are both tasteless. I just have to keep mentioning that. Now, another thing is, it's important to dose it into a sufficient amount of beverage. Most people, when they taste nanoemulsions, either they put them straight in their mouth, which is not how your customers will be consuming them, or they put it in a little bit of water and they don't even measure how much they're putting, just to kind of see the worst case scenario, which is reasonable, I understand, but then you are going to see the worst case scenario. So in the real world, you would be putting it into a larger than that amount of water, and that really helps with the flavor as well. You can also select beverages with compatible flavors. For example, if you dose a cannabis nanoemulsion into beer, I personally can't feel anything, and I don't know anyone who can, if the nanoemulsion is good, unless it's like very chemical and uses wrong surfactants. Because beer, especially with hops, has very complementary flavors. Hops is very similar to cannabis in as far as the plant goes. So many of the flavors and smells are the same, so it gets lost in there. Same for coffee, same for many teas, things like that. Now, if all else fails, what you can do, and if somehow you really want a tasteless formulation, you can try to use a bitter blocker. We offer bitter blockers, which themselves are also nanoemulsions. So you can administer them, you can dose them into the same place you're dosing a nanoemulsion. So this would be your nanoemulsion, you would put separately from that, you would put a bitter blocker into it, into the same beverage, and you would have to titrate, you would have to kind of go by taste and determine how much of this you need. It's not one-to-one, it's a lot less than one-to-one, but it depends on each person what they believe is enough. So bitter blockers are available. If you are interested in one, come talk to us. Another thing that we offer, besides enabling others, we have started fairly recently to do contract manufacturing, and it's a very popular new aspect of what we do. It really took off right away. So for those who don't want to make their own nanoemulsions, we can make them. We can make them for you. We can make them using your extract, if that's what you'd like, or we can use an extract that we ourselves acquire from a source. We have a source that we like to work with, but it's up to you basically to tell us if you'd like a different source. So what we can make for you are liquid nanoemulsions based on nanostabilizer LT, liquid nanoemulsions or nanoemulsion powders based on nanostabilizer LSO. And for those who want a premium powder, a powder with nanoemulsion droplets after reconstitution that are much smaller than 100 nanometers, a powder that will go clear when you dissolve it, as I showed in the first slide. We have yet another nanostabilizer formulation. It's called nanostabilizer LST, which we don't offer as such. We only use it for contract manufacturing to those who want premium powders. The powder looks like this at the bottom, and the droplet size distribution, as you can see, is under 100 nanometers with the median droplet size of 35 nanometers. It goes in a beverage clear. It's very quick to dissolve. Its bioavailability is very high. So onset of action is immediate. By immediate, I mean about 10 minutes, because you still have to get to your small intestine first, unless you keep it under your tongue, which speeds it up further, for which you can make tablets out of it or other things like that. And lastly, I'd like to talk about stability, which is also something that comes up. Nanoemulsions are physically stable, meaning they won't separate, the oil won't float. But that doesn't mean that they are stable as far as chemical stability to oxidization of your bioactive. For example, CBD or THC are very susceptible to light. So if you keep them in a glass container, even not really in direct sunlight, just somewhere in a lab, then we notice that after about half a year, they start to oxidize, and the concentration of CBD, in this case, starts to go down. If you keep the same nanoemulsion in a dark glass container, so this was back to back, they just keep going. So in a dark glass container where light can't get to it, If you don't open it all the time so that fungus can't get to it, they last indefinitely. And with this, I'd like to thank you all for your attention, and we're happy to take questions.
Thanks, Alexei. All right, so we have about 10 minutes left, so we are going to jump straight into the first question. What is the shelf life of a nanoemulsion prepared with nanostabilizer LT or LSO?
Great question, and I think it's addressed pretty much here. Let's see how I can go back here. Yeah, it's addressed in this slide. It's physically stable indefinitely, and it's chemically stable indefinitely. We still have some nanoemulsions we made more than 2 years ago, and nothing has changed about them as long as they're kept in a dark glass sealed container.
And what is a stable temperature range for finished nanoemulsions? If they're exposed to temperatures outside of these ranges, what happens to them? Do they become just emulsions? Do they separate?
Yeah, so there are two things you don't want to do with a nanoemulsion. You don't want to boil it, and you don't want to boil it because then you basically detach the droplets from the water, because water becomes gas, it becomes steam. And you don't want to repeatedly freeze them and thaw them. If you freeze them one time and then melt them back, the droplet size will increase somewhat. It'll still be stable, especially if you melt them slowly. But if it goes through this kind of cycle, then eventually they will separate. Now, if you keep them between, let's say, 4 degrees Celsius in the fridge, in the refrigerator, and something like 80 degrees in the shipping container that is going through Florida in the middle of summer, they are typically stable against that. If you keep them at room temperature, you're also fine. For the nanoemulsions I mentioned in this slide were both kept at room temperature just in the lab on the workbench.
And speaking of droplet sizes, what equipment can be used to measure droplet sizes of nanoemulsions?
We recommend dynamic light scattering if you are talking about nanoemulsions in the range of something like 20 nanometers and up to about 150 nanometers. Above 150 nanometers, you can still use dynamic light scattering. That works well. But now you also have the option of using laser diffraction, which many people prefer. It's easier in several ways to use, but it's not very good with very small droplets. So if you're in the translucent nanoemulsion range, dynamic light scattering is the clear winner.
Great, thank you. I have a question for Jeff regarding contract manufacturing. Can you do this with THC or just CBD? And do you have contract manufacturing in other states than Florida?
Yeah, that's a great question. So we offer contract manufacturing based out of our offices in Florida, but not for THC. So for CBD and some other products, which I'm happy to go through that list with whoever has that interest. But we also do have an opportunity to work with different people in different states around the nation that we know have the capability to create those types of finished water-soluble nanoemulsions.
Excellent. This is a question for Alexei. How long should 1 liter of nanoemulsion be sonicated for?
That depends on what processor you're using. If it's an LSP 600 processor, then it's about 1 hour per liter. With BSP 1200, 5 liters an hour is the productivity rate, so whatever is about 12 minutes or so. With ISP 3000, it's about 20 liters, 20 to 25 liters per hour, so that makes it about 3 minutes.
Excellent. We have another question. What is the highest concentration of CBD isolate that can be nano-emulsified using the ISP 3000 and nanostabilizer?
That depends on the target droplet size. If you're trying to stay in the translucent nanoemulsion zone, with median droplet sizes in the vicinity of, let's say, below about 35 nanometers. The highest recommended concentration is 50 milligrams per milliliter on the CBD basis, or about 5%. Same thing, just different units. Now, if you don't have a problem with larger droplets, you could go much higher. We've done easily up to 20%, so 200 milligrams per milliliter. And it could go higher than that. I think we've had some situations where we went all the way up to 30% or 300 milligrams per milliliter. But then the droplets do grow, although nanoemulsions are still stable. Everything I mentioned is an actual stable nanoemulsion that could be used as a product. Above that, you could have some somewhat unstable nanoemulsions, which I don't recommend that you do. And this is on the liquid side. On a solid powdered side, using an LSO nanostabilizer, you can go up to 200 milligrams per gram. In this case, it's not per milliliter because it's solid, so milligrams per gram, or 20%, easily and without the increase of the droplet size. So you would still be in the vicinity of 150, 170 nanometers for the droplet size at 20%.
Excellent. Another question here, how do you measure the concentration of cannabinoids in nanoemulsions?
Well, first of all, if you trust your extract, then what you put in is what you have. Because the process itself doesn't destroy or create cannabinoids. If you actually want to measure it, then we recommend HPLC. When you use HPLC, it's important that your mobile phase, not all labs know this, so if you're going to send it out for analysis, it's good to mention it to them. The mobile phase has to be water compatible. Typically, methanol is your mobile phase. In that case, HPLC is a very accurate technique that can go down to very low concentrations, so you can measure it in your finished product after dosing or in its concentrated form after you first make it.
Next question is, are nanoemulsions recommended for cosmetics?
They can be because they are easily incorporated into water-compatible formulations. So if your cosmetic product is based on water or has water in it, then nanoemulsions are convenient because you can easily disperse the bioactive throughout your cosmetic product. If your cosmetic product is transdermal, meaning you have to get through the skin and all the way to the bloodstream, nanoemulsions can definitely help with that. There's a class of formulations called Nanoemulsions, where basically it's a nanoemulsion that you gel and dress up with other things that make it a cosmetic product that can be used for patches or creams, and bioactives have a way into your body through the skin without having to use DMSO and solvents like that. If it's a topical application, then nanoemulsions are good because they can be incorporated in formulations that easily spread. But if your cosmetic formulation is oil-based, you don't need a nanoemulsion. All you need to do is just dissolve a cannabis oil in that oil-based formulation, because cannabis oils extracts dissolve in oils, so you don't have to do anything as complicated as making a nanoemulsion for it.
You reference high bioavailability. Have you conducted human studies to show this? It's another question.
Yeah, good question. We are in the middle of one study now. Unfortunately, got delayed because of COVID. We were ready to go about a year ago, and now we're still ready to go. But it's starting to happen. This is a study with University of Miami, where we'll be administering gel caps of CBD oil versus nanoemulsion dosed into water, same concentrations, same doses in both cases, to a fairly large group of volunteers and then taking blood samples as a function of time, building the graphs. We have done unofficial THC self-reported effect studies, which can be seen in a couple of presentations I did. I don't have time to go through this now, but we'll make sure to put a reference later for people to be able to see the results of that study. So that study confirms the slide that I showed you previously, the bioavailability increase and the shortening of onset of action. And after these fairly simple studies are done, our plan is to recreate the droplet size study that I showed you with an actual cannabis extract, probably with CBD, possibly with delta 8 THC.
And I believe we have time for one more question. Let's see. This is a question about bitterness. Is the bitterness disguised by the bitter blocker to allow taste of terpenes to be less bitter, or not to taste like anything?
Yeah, that's a great question. We don't know yet. Bitter blocker ideally would just block the bitterness, but not other things. That doesn't seem to be what it actually does. It makes things seem like there's nothing there. Does that include all terpenes? I don't know yet. This is something fairly new to us. We're looking into it. Bitter blockers don't work in every case. They work remarkably well in some cases and not so well in others. And we're now really starting to look at and why that might be. But I don't expect there to be a bitter blocker that is so surgically precise that it will just get rid of one taste component while leaving others.
Excellent. Thank you, Alexei and Jeff. And thank you, everyone, for attending the webinar. We have another 100 questions left, so we'll try our best to answer them offline and provide the answers. We'll also post a recording on YouTube once it's available. We'll email everyone. So we hope to see you at our next event. Have a great day, everyone.